So before starting this very brief presentation on a software, let me just reiterate that this is one component of developing a causal loop diagram, and that Vensim is a software to help one organize the data that they collect and hopefully make it easy to understand. So that's where what Agnes was saying is, trying to think about subsystems, try to think about how to communicate these things, and not necessarily complexity in that case isn't always very helpful. So trying to be mindful about that. So we'll do a very brief overview of the various features of Vensim, which you can follow along if you have it open, and then we'll go into hands-on exercise. So the purpose of today is just to introduce you to a software, like I said, and this is a free software. That's one advantage. It's not necessarily the most user-friendly software, but what's nice about it and what ties in together with tomorrow's session is that it can also be helpful to draw stock and flow diagrams. So it really can help with the whole, two types of system dynamic modeling, and two which actually fit, one can build on the other. Today we're just talking about causal loop diagrams, and this is the website. I think I've already sent it to you in email, but so most of you should have it. And as I mentioned, tomorrow we'll be looking at stock and flow diagrams, but basically the causal loop diagrams, we'll just talk about identifying feedback in the system and identification of different variables and with opportunity for using brainstorming. So, and you're welcome to follow along in this tutorial. If you open Vensim, it's this sort of sunrise symbol that you'll find, at least that's how I interpret it. And then if you open, if you click on the new model that's on the toolbar on the upper side, you'll get some questions about time steps and whatnot. Just click OK, that's more relevant for tomorrow's session. And then you'll have a blank screen. And just to give you a flavor of what we'll talk about a very simple infectious disease scenario. It has only 3 variables: a population infected, new infections, and a population that's susceptible to infection, or individual susceptible to infection. And going back to what Agnes presented, we'll be talking about 5 different elements. One is the variables, the causality, polarity, feedback, and delays. And these are the 3 variables that we'll use. We'll be looking to see how they relate to one another, both in terms of direction and also causality. And then we'll be looking to see at what types of loops are potentially formed with these ones and try to label them. So to create variables, there's the toolbar at the top of the screen, and you'll see that there's a variable button. So you can start by creating 3 variables in your workspace. Can you see? Oh, I'm sorry. It gives you a screen. Yeah, just press OK. That's more important for tomorrow. Oh, no worries. And please interrupt me with any questions and let me know if I'm talking too softly. So you can create the 3 variables. You can even create 1 or 2 just for illustration purposes. And know that if you make any mistakes, it's very easy to delete them. To create the variable, you go in the upper left, upper toolbar, and just a few steps from the left, there's a variable button. And then you click anywhere on your workspace, and then you're able to type in what variable you would like. And as Agnes mentioned, these are usually nouns. You would prefer to avoid directionality in the actual variable because that's what you want to illustrate with the arrows. Has anybody who has developed causal loop diagrams before? Could I have volunteers to? But this is just to tell you that I'll continue moving because I think we want to introduce you to the software, but really the purpose is to get a flavor of what it's like to build causal loop diagrams. So I think through the model, you'll be able to figure that out. And many people still develop these with pen and paper, so it's not something to deter you from doing them. So after you create a variable or a couple of variables, on the same toolbar, you can click to create arrows. And you have to first select the arrow button. And then after that, it's quite straightforward. You just click on the first arrow and the second arrow, the second one being the one in which the direction of causality is going. So you have to do 2 clicks, one on the first variable and one on the second variable. Does anybody have any questions about this step? Does everybody have an arrow? And then what's next is that for each arrow, you will want to eventually add arrow properties. So in order to add properties, you right-click on the arrow. As you'll see, it has a small circle in the middle. And if you right-click that little circle on the arrow, it gives you a variety of options. And there's the little arrow. So if you right-click on the sort of middle of the arrow, you can add either a polarity or a delay. You'll get a screen that looks sort of like that. It's a gray screen with many options, which you'll want to maybe just familiarize yourself. Basically, you can add polarity. It's sort of in the middle of the screen. You can also add a delay mark if you at some point anticipate that there is a delay, similar to what Agnes showed in her case study. And for, I guess, design purposes, you can also position the arrow, whether it's at the arrowhead or at the handle, inside or outside the arrow. So that's the other option that you have. And of course, you can look at color and lines. Yes, please. The bumping into one another? Mm-hmm. So maybe let's see. If an infected bumps into a susceptible, there's a new infection. Right. And I think you can illustrate that statement when we look at the entire diagram. So I think once because right now I guess I selected the new infections to connect them, but I think when we look at the 2 of them together, that statement will become apparent. So can we follow up to that question when we get to the diagram? Yeah. Are there any questions? If not, I'm going to move on. So the 4th step, after you add variables, you add arrows, you add properties to your arrow, then you want to label the loops, right? So eventually, based on the information that you have handy, you're going to have some loops, and in order to label them, you have to click on the comment button. And that's another button that is found on the toolbar. And you click wherever you want this comment to be. In this case, I guess I'm suggesting the middle of the loop. And then you get another set of options, but let me just guide you to some important parts of that menu. Basically, there's a comment section, and there you can write in your comment. Another thing that you can do is you can add a clockwise or counterclockwise loop, and this is has nothing to do with the reinforcing or balancing, which you denote either through B or R or plus or negative, minus. But really it helps the reader, especially in more complex diagrams, follow the direction by which they should read the diagram. So in this case, the more new infections you have, the least number of individuals are susceptible to being infected. But the more susceptibles you have in this environment, after a while, depending on the infection rate, there's a delay, there will be new infections. And this is a balancing loop because, as Agnes mentioned, any volunteers to why this is a balancing loop? It's a balancing loop because we don't have there were some variables that move in the same direction and some that in a different direction. Any questions at this point? Step 4? So we'll keep moving on. As Agnes mentioned, there are multiple ways to label loops. Most people in journal articles use either the plus sign or the minus sign, plus for reinforcing, minus for negative. Vensim also have this feature where you can add the snowball effect or the seesaw, where your goal is to seek a balance, an equilibrium. And you can add those, if you want to add an image, it's the same comment box as before, and you can select it from there. So, as I mentioned, drawing is one thing, and Vensim is supposed to help you draw. You can do the same thing with pen and paper. But what is mostly interesting is after you have outlined your causal loop diagram is to really think about, well, what does the feedback mean? Is it desirable? Is it undesirable? Where is it coming from? What are the variables that are missing? And what is influencing the delays? And in discussions about the variables, how they connect to each other, the broader mindset of the broader motivation about doing this causal loop diagram, there's also the discussion of where and why to intervene. So that is the very brief introduction to Vensim, basically to show you how to write out variables, how to connect them with arrows, how to label these arrows, and how to then interpret the loops. But really it's a discussion tool, and I think that hopefully through the hands-on exercise that we've prepared, you'll be able to get a better flavor of what this adds perhaps to other types, in contrast to other types of diagramming, and perhaps how it might be useful.